All right, guys. Suppose that 500 is invested into an annual interest rate of 6.5%. Find the final amount of the investments after 10 years for an interest compounded continuously, okay? So because it's compounded continuously, guys, we're going to use the equation A equals P times E raised to the R times T, all right? Now, remember your parts. P is your principal. All right, so that's our principal. E is E. All right. R is our rate, which we're going to convert that, guys, to a rate of 0.068. All right, convert your percentages. And T is going to be 10 years. So you take it just like that. We got to find A. So our principal is 500. All right, times E. To the 0.068 times T, all right, which is 10. Now make sure you put parentheses around this exponent, guys, in your calculator. All right, so it looks something like this: 500, all right, times E, remember, second, and ln, because natural log is right, excuse me, E is right there. All right, we're going to go 0.068, all right, times 10. Now, my calculator superscripts this. If your calculator does not raise it like this, put parentheses around that. All right. But anyway, you get $986, guys. $986.94. All right. Okay. Now, it says how many years does it take for your investment to double? All right. Our investment, we don't know what that is, but our investment is P to double. All right. With an interest rate of 9.2 compounded continuously. Also says how many years, guys. So that means how many years we're looking for T. All right, we got to find T. All right. So look, we don't know what our investment is. All right, but we know that it doubles. So we're going to say 2P. All right, it doubles. This investment doubles. So 2P. All right, then we just continue it. All right, 0.09. All right, times T. All right, we don't know what T is, so we're going to do it like this. Now, the first step, if you remember from class, is you can divide by P on both sides. All right, let's go ahead and divide by P on both sides. All right, if we do that, you end up with 2 equals E. Hold on, I need to make some space so I can show you the next step. 2 equals E to the 0.092 T. All right, I just wrote it like that. I don't have to put the times. It's the same thing. Okay. Now, the next step is how do I get rid of this E? All right. Well, we learned a technique. You can multiply by its inverse of ln. All right, on both sides. So take the natural log on both sides. All right. What happens is the natural log and E cancels. So I'm left with 0.092. And on this side, I have ln of 2. Okay. Now, to finish this, since I'm solving for T, I simply divide by 0.092 on both sides. All right. Over here, it cancels. So I'm left with just T. All right. And right here, we can do that in our calculator. If we go natural log, ln's right there, guys. Natural log of 2, close that parenthesis. All right, make sure you close it or you'll get something completely wrong. But divided by 0.092. All right, and that gives us 7.53. Okay, so there we go for that, guys. Now let's keep moving. We're going to write as a single log, I believe. Come on, convert. All right, here we go. So I can zoom in and have more space. To write this as a single log, guys, remember, first of all, we take this 4. It needs to go back to being an exponent of x. All right, so that gives us log base z of x to the fourth plus log base z of y. Okay. Now, because I have the same base of z and I have a plus, we're going to multiply this argument right here and this argument right here. All right. So our final answer is going to be log base z, all right, of x to the fourth times y. This is our single log right here, guys. Single log, okay? Over here, let's see here. We need to evaluate the parentheses first. All right, evaluate the parentheses first. So what I'm going to do right here with this 2 is move it back to this side of the y. And for the sake of it, I'm also move this 1/3 right here back to this x. All right. So we end up with here. Let me do it on another page. So here's what we got: 1/3. Oops, not 1/3. We just said we're going to move that, right? So we have log base 4 of x to the 1/3 minus log base 4 of y squared plus log base 4 of z. Okay. Now, remember PEMDAS, all right? What comes first? Parentheses. All right, parentheses. So I'm going to evaluate this parentheses first. All right, I have the same base and a plus, which means I multiply this with this. So you have log base 4 of x to the 1/3, all right, minus, now let's do this part right here. If I put this back as a single log, you end up with log base 4 of y squared times z, all right. So now this is multiplied because of the plus. So now I have a subtraction here, all right. Subtraction tells us I need to divide this argument and this argument, all right. So we're going to divide x to the 1/3 by y squared times z. So I get log oh man, come on, all right, log base 4 of divide this and divide this. So x to the 1/3 divided by y squared times z. All right. Here's your final answer on that one, guys. Okay. All right, guys. Let's go ahead and look at number 14. Oops. All right. Well, 14. Let's see here. We have these numbers out front, so we need to move those back. We're going to move the 5 back to here, and move the 3 back to right here, and move the 2 back to here. So we're going to have log base 4 of a to the 5th plus log base 4 of b cubed, all right, plus minus log base 4 of a squared. Okay. Now, remember, work these from left to right. All right. So we have the plus here first, same base with a plus. We're going to multiply this one and this one, these arguments. So that gives us log base 4 of a to the 5th b cubed All right, we still have minus log base 4 of a squared. All right, again, I just brought this down. All right, brought that down. Now, right here, what do we do with this? Well, same base and a minus. So we're going to divide this argument and this argument. So you end up with log base 4 of, let's do it like this. Of a to the 5th b cubed divided by a squared. Now, the thing I want to point out is right here. So I have a to the 5th up here and a squared here. All right, well, what's the rule when you have the same base, all right, and these exponents? All right, when I'm dividing, you can subtract that. All right, so 5 minus 3 is 2, right? I'm sorry, 5 minus 2, 3. So 5 minus 2 is 3, but the larger one is at the top. So that means it's going to stay at the top. So here's what we get. Final answer. Log base 4 of a cubed b cubed. And again, 5 minus 2 is 3. All right, so here is your final log, guys.